Alright, today I'll be introducing the light-sensitive Beehive entrance, which can be integrated into any traditional beehive. The designers behind this product are Ryan Broderick, Neil Mehta, and Teddy Thurgood. Prior to creating this design, we talked with two beekeepers who have experience with bees as hobbyists. They discussed the challenge of diagnosing problems that occur within the hive itself. Based on this, we thought it would be a good idea to increase the protection the hive has to outside influences, and they hope to reduce the amount of negative problems within the hive. With the limited amount of time and resources the team possessed, we set out to accomplish this goal. One of our main goals was to ensure that the relationship between the hobbyist beekeepers and their hives was not diminished. The whole reason they wish to be beekeepers is to interact with the hive and learn all they can about the bees, with the side benefit of being able to brew their very own honey wine, or in other terms, their own supply of mead. Now, to create this desired beehive, we had to first go through many different brainstorming options. We discussed a sensor that could alert the beekeepers as to when the honey is ready to be harvested, and we also discussed a way to change the color of the harvested honey. In the end, we decided on the automatic door since it would provide the greatest protection to the hive itself. This door would remain open during the day when the bees are active and automatically shut at night when they aren't as active. This front door would provide the bees with protection from outside pests during the night, while giving them access to the local gardens and flowers they need to pollinate and collect the nectar they need to build the honey. In addition, this design does not take away from the beekeepers' interactions with the hive itself. Two proofs of concepts were built to illustrate our rotating door and pivot ideas. The picture on the left is a door that rotates around its central axis, and the picture on the right is rotating about its side edge. We went with the picture on the left because it had the shortest rotation while providing the same amount of protection. Our final functional prototype depicts the hive with a small electronics housing on the side for the microcontroller and battery pack. The side compartment was built to isolate the sensitive wiring and electronics from interference from the bees themselves. An enable switch is also located on the side with the photoresistor that acts as our light sensor. The housing has a removable lid for easy access to the electronics should the batteries need to be replaced. Our system is comprised of an Arduino 101 microcontroller, which takes input from the light sensor and enable switch and outputs a signal to the RC servo motor, which then controls the open or closed position of the door. When the sensor value is red, it is mapped to its desired range. If it is dark outside and the switch is enabled, the servo will rotate to its closed position. Otherwise, the door will remain open. Here's a quick demonstration of our system at work. As you can see, the door is initially open with the light on, but when the light is turned off, the door shuts as well. Our product provides a function that isn't available on the market today. In addition, our product possesses the ability to limit pests with an actuated door while not interfering with the daily life of the bees. It is also easy to implement in a variety of hives, and most importantly, it does not inhibit the relationship between the beekeeper and the bees. Thank you very much for watching.